start by looking at just how to evaluate exponential expressions. And we are going to be using a calculator for this. And so the idea is we're looking at powers. Okay? So in the first thing, if you just look to evaluate these using a calculator, okay, if you're using TI-89, okay, what we're looking to do is you type your base exactly as it appears. This caret symbol is your power of, and then whatever the exponent there is, you enter, and that will be your solution. So in this particular case here, 1.003 to the power of 100 is 1.3493 if you round it to 4 decimal places. Okay. Let me talk through what you would do if you were using the non-TI-89 calculator. Okay. If that was the case, and let's say this is the calculator you're using. When you enter your base, 1.003 to the power of is this button right here. It'll be something similar on the basic scientific calculator. And then you type in your exponent, and that gives you the same exact thing, 1.3493. You can use any calculator for that. Okay, now, in this particular case, if you're being asked to round to at least 4 decimal places, let's say you come up with a problem like this, 8.69 to the power of, in this case, 7.98. And then the change of sign key right here, you'd enter it after you type in the whole thing. Most calculators will be like that. The TI-89, you can type it in before. But notice that this has the letter, this e to the minus 8. Okay, that's scientific notation. Okay, so this one right here, this is not a good problem. I'll go in and double check them before I open this assignment. But for this, if you were rounding it to 4 decimal places, it would be 0.0000. It'd just be 0. Okay, but I'll try to get those fixed so that the numbers are big enough that you can enter them. But if I were to write this in scientific notation, you have 3.2109. And that was 10 to the minus 8. And so that would be your answer. Again, you shouldn't have to worry about that. I'll go in and fix it before I open that assignment. Okay, you might also have expressions that have the letter E. Okay, E is called the natural base. Okay, you'll learn more about E next year, but for now, we're just going to do some calculations with it. Okay, the natural base it's kind of like pi. It represents an irrational number, and the irrational number is this quantity as n approaches infinity. So what you would see in this is the growth factor for exponentials. That's why it's the given e. Okay, it is an exponential growth factor. As the variable here approaches infinity, as this gets bigger and bigger, the value never stops growing, but it grows at such a small rate that you start to not notice those differences after n reaches a certain number. It's about 2.718, just like pi is considered 3.14. And so that's the approximate value of this. And what you'll see is as you let n be numbers greater and greater, it starts to get to this point. Once it gets past this point, only the digits that fall after that are changing. And so it's something that is used in exponential growth functions because this is a growth factor here. Okay. When you are evaluating on your calculator, on the TI-89, the natural base is located right here above the x. So you would type this in as 9 diamond x gives you e to the power of, and then 10.01. And that gives you your solution here, 200,000, 230.5191. So 200,000, 230.5191, and that would be your solution. If you were using the basic calculator for this and you were evaluating E, it's also going to be on here. Now, when you try to look for your e to the power of, you don't see it in this screen, but what you do see here is that this ln is called a natural log. We'll learn more about that later in the section. But if you hit this invert button, the inverse of the natural base is the natural log, ln. Okay, so if you want to find it, again, most of the calculators that you'll be using that you have access to, you'll see the e to the power of x button. It'll be along, like right at the same place where ln is. Okay, so in this case, it's inverse here. And so what you would get for calculating this problem is you could take 9 times, we'll write 10.01, and we'll use the natural base here, and that's going to give you your answer, 200,230.5191.